Hello everyone. In this program, we'll study some matrix operations using NumPy library. So firstly, we'll create a random 2D matrix. So let's say matrix is equal to np dot random dot randint, and the range will be 1 to 100 and size will be 3 comma 3. Okay. So we'll print is the original matrix. Okay. Now, what we'll do in this program is we'll handle basically there are some errors that can occur basically in matrix operations. Okay. If we want to calculate determinant and inverse, our matrix should be a square matrix. So how can we check whether the matrix is square matrix or not? So here we are creating a matrix which is 3 by 3, so there is no problem. But what if we are taking the existing array and existing 2D array or a nested list and converting it to an array? So we perform some checks, right? So for example, check can be matrix dot shape. Now matrix dot shape is a tuple, right? It has number of rows comma number of columns. So number of rows is index 0. Index 0 contains number of rows. If it is not equal to matrix dot shape 1, there is value error, and we can add some custom message to the exception. So basically we are passing this string to the constructor of the value error class. Okay. So matrix must be a square matrix for calculating determinant and inverse. Right? Then for calculating the determinant, we'll use okay, let's say determinant equal to okay, determinant equal to np dot linear algebra library is written as linalg. There is a linalg library, linear algebra library dot det. Det is the name of the function, and there we pass our matrix. Determinant value will be in the determinant, and there is another check. Okay, so we'll first just print this. Determinant is, and before we calculate the inverse, there is an essential check. If determinant is not equal to 0, only then we can think about calculating the inverse. INV function is used for calculating the inverse. Okay, so we are avoiding all the exceptions that may occur, because otherwise, like, this is a check that we have done, this is our own exception that we have raised over here. But even if I don't do this, if I have some rectangular matrix, let's say 3 by 2, 2 by 3, 3 by 4, whatever, and if I try to calculate its determinant or its inverse, then there will be a linear algebra error. Okay, which I'm avoiding over here. Okay. Else, if the determinant is not 0, you will print the matrix is singular. The determinant is 0. The matrix is called singular, which you must have studied in linear algebra in your high school. Okay, so the matrix is singular, its determinant is 0. Okay, singular means inverse does not exist. I don't think it's necessary to write that in front of it again. Okay, so we can put the entire thing in a try except block. Okay. Handle any exceptions that may occur. So exceptions can start occurring from here, right? So this entire thing I will tap forward except value error as E. I did not print anything separately over here. I can simply print E because E will already contain whatever I have raised over here. It will be except that will be caught over here and printed over here directly. And another exception can be in general, any exception like linear algebra error or any other exception, memory issues, anything, we have handled the error. Okay, so let's run this. Let's run it afresh. Also, original matrix here will the backslash n so that it gets displayed properly. This is the 2D matrix, 2D, sorry, this is the matrix. Okay. Oh, sorry, here I should write determinant, not det, determinant. Okay, so this determinant is this. I did not print the inverse. Okay, my bad. Inverse is this. Inverse matrix is inverse. Okay, okay. Original matrix, determinant, inverse matrix. Okay. So that's it for this question. If you have any questions, any doubts, do post them in the comments below. Thanks for watching.